What the agenda we are going to follow today during this master class? Data science overview, trends, technology, and typical application you can perform if you have the skill set of a data scientist. Then data science concepts. What are the concepts are necessary in order to build a data science projects and best practices, right? So what are the best framework and the practices which will support you to pursue, complete, and win with the data science projects? Data science popular code, which are typical the programming language and the code which are trending in the marketplace or on demand for a data scientist. Data science with no low code tools. Not necessarily you need to be a coder in order to become a successful data scientist. You can perform each and everything using a no and low code tools. During these sections, you will be exposed to one of the software called Statistica for the no low code tools. Data science, data to deployment, right? So how from the raw data you can complete the best practices and the framework, and you can perform a capstone projects. The next steps, then questions. So this will be the agenda for the today's session in masterclass. Before getting started, let us have a disclaimer. Uh, the data science masterclass is intended solely for learning and informational purposes, right? The session does not constitute professional advice, certification, or job assurance. Examples, datasets, software tools, and methodology shares are illustrative and may vary in real-world application. Participants are advised to independently validate concepts before implementation. The organizers, speakers, or associated institutions shall not held responsible for any direct, indirect consequences arising from the use or interpretation of the information provided during the masterclass. Submission. This is our first and the initial edition of masterclass. More advanced session will be followed soon. First and the initial edition because in the public domain, however, we have done more than 200 uh, the session for on invitation, right? So we have been receiving invitation and we have been delivering successfully. This is the first time we are conducting this master class by inviting people to join our session or in a public domain. This data science master class is not an exhaustive training program. Rather, it is designed to provide essential skills, foundational knowledge, and career preparedness needed to begin or enhance your journey in data science as a career destination. Right, so let's get started. Data is everywhere, right? So this is what is happening around us, the data related activities, right? And today, like you must agree with me, no research is complete without data, right? So this is what is happening around us, like 2 million searches are happening in every minute of every day. 72 hours of video are being uploaded in the YouTube, right? 70 domains being created in every minutes of every day. 41,000 Facebook communications being done in every minutes of the every day. Now, this is what is happening around us through the internet. 24,88,887 mails are being exchanged from one to another end, right? Using email. Sorry for a little interruption. So this is what is happening around us using the internet. Again, this is the infographics I shown you. These two infographics we have been using since over a decade from now, since the data has been growing exponentially. This is one of the new infographics in 2018, right? Nothing has changed, only the volume of the data has increased exponentially, right? What is the message for you, right? So we all agree, no research is complete. Data is the new oil for every innovation and the research, so and so forth. In order to get a victory, and all this data has bring us an opportunity, this data has brought us an opportunity. In order to get a control over data related activities, right, we need to master in this 4P, right? And another exciting information, 90% of the today's data has been created in just last 2 years, right? So there are enormous opportunity in the data related activities. Another challenges has come. 90% of the data being generated are unstructured data in formats, right? So in order to get a control over the data, you need to develop a skill set in terms of volume, how you can deal with this voluminous data it is being generated, the speed of the data, right? So what we saw in 1 minutes of every day, 1 seconds using internet, diversity of the data, the variety of the data, as we see, the 90% of the data are the unstructured data, right? So we need to have the skill set how we can deal with the structured data, semi-structured data, unstructured data, so and so forth. Then we have the veracity, the certainty of the data, right? What typically like the data engineer they do, right? How you can ensure the data pipeline from the source of the data, you can have the skill set in order to ensure the data to ready for analytics. If you have the control over these skill, volume, velocity, variety, and veracity, then you have a victory over the data and you can create a greater value from your ocean of data. In order to deal with these challenges, right, as I said earlier, all this data bring us an opportunity, right? So in order to deal with these challenges, there is a new discipline has come in form of data science, right? So what is the data science is all about? What are the components are included in the data science? Data science includes databases and data processing, visualization, statistics, pattern recognition, machine learning, data mining, AI, or denotes to artificial intelligence. These are the necessary components of a data science, right? And what you see in the infographics, the upper sphere, right? Like skill for problem solving, your critical thinking or the business analyze, business strategy, domain knowledge, communication, presentation, inclusiveness. These are the soft skill which will combined with this skill with the soft skill that will make you a rockstar data scientist, right? If you aspire to, because suppose I split this infographics in two parts, right? Left and right, right? If someone has got the skill of databases and data processing, right? Visualization, statistics, not to worry, they are eligible for data analyst, business analyst, financial analyst, actuarial analyst, so and so forth, right? If you have all these combination, then you become a data scientist. Even under the data scientist also, there are multiple positions are on demand, the skill set. If you understand machine learning very well, you could be a machine learning engineer, right? If you understand the AI, not all the component of data science, but you are a master in AI, still you have an opportunity for the AI engineer, right? Data mining, right? Data mining, the data science is for us, it is nothing. As I said, we have been around since 2007. What we have seen, data science is nothing but that is an upgrade of data mining, right? So these are the positions are available in the market, which are trending in the marketplace. This is the broad classification and skill sets are required for data engineer. As I have been talking, data pipeline, getting the data. So these are basically like skill set, focus. What is the goal of a data engineer, right? Building data pipeline, right? The skill sets are on demand like the SQL database, right? The coding, Python, and the Spark. Spark, again, it's a language for data pipeline. Motto, like how I can bring the data from the databases, right? What is the skill set of a data analyst? Focus, interpreting data, skills, SQL, Excel, Tableau. Tableau is a visualization tool. What we saw in the infographics, visualization. Then insights. What the insights, basically the job of a data analyst or the business analyst or a financial analyst, they bring the 360-degree of view of the data you have, right? But the data analysts broadly, they are not into the business of the prediction, right? So that makes a difference between data analyst, business analyst, financial analyst, actuarial analyst, right? And a data scientist. Once you see modeling the data, right? Modeling the data will be coming into when we come to the best practices. What does this modeling of data means? The skills required by the industry, Python, R, machine learning, motto, algorithm, right? So this is like the broad skill set, a little more expanded skill set you require. Like if, as I said, for a machine learning, what kind of the learning algorithms we have or the problems we approach and solve, we have with the machine learning. Under the machine learning family, we solve the classification problem, we solve the regression problem, we solve the reinforcement learning problem, we solve the deep learning problem, we solve the clustering problem, we have the dimensionality reduction problem, so on and so forth. In data analysis, we solve like feature engineering, data wrangling, EDA. EDA denotes to exploratory data analysis, right? You see, in data science, it is showing, right? Math. Math is the key differentiator between a data analysis and a data scientist, right? Under the math, for a data scientist, it is necessary to understand statistics, linear algebra, differential calculus, right? What are the languages? Programming languages are trending in the marketplace. Python, R, Java, but not necessarily as we have been talking about. We are going to show you all in one. All these languages you can perform, not necessarily like suppose you do not know Python or R, you cannot get into data science, right? We are going to show you in a couple of minutes. Data visualization, as we saw in the last slide, Tableau is one of widely used data visualization tool. Similar kind of the tool also available in market. Tableau, Power BI, Matplotlib, ggplot, Seaborn. These are the library for the visualization from the open source, right? Matplotlib, Seaborn, these are for the Python library. ggplot is from the R library in order to perform a visualization. In addition to the Tableau Power BI, we have a couple of other tools also like your uh, uh, For data visualization, like we have Dundas, we have ClickView, we have Spotfire, so many that is also very popular in the marketplace. Then we have the IDE. IDE denotes to integrated development environment. These are the IDE which interacts with your programming language like Python, right? Like PyCharm, Jupyter, right? Spider. These are the Python IDE. Colab, it's a Google IDE. Then RStudio, that is exclusive for the R language, right? Then, like as we have been talking about the data to deployment, right? So how we can deploy, you need to have the skill set. These are the popular deployment tool, AWS, Amazon Web Service, and the Microsoft Azure, right? These are the engine where you can deploy your model from data to uh, uh, deployment, or you can say democratization of data science. When you build a model, millions of people they can benefit from once you deploy the model for the purpose of prediction or scoring. Then web scraping, like suppose you wanted to retrieve your data from weblog or websites, like as we saw, 90% of data comes from the unstructured format. And the web scraping or the weblog websites, these when we elaboration from machine learning, under the machine learning, we broadly it classify into the two part, supervised learning and unsupervised learning. And under the supervised learning, like once we have a target in place, right? We have a supervisor in place, then target means suppose I do have a response variable, right? If the response variable labeled with classes like yes, no, good, bad, right? Heart disease present, absent. Suppose these kind of my response variable comes along with the label, then it becomes a classification problem. If my and these are the popular algorithm from the classification, support vector machine, discriminant analysis, need-based, nearest neighborhood. In the regression, we have I do have a target, but I do have the target in numbers. Like suppose I wanted to predict the stock that comes in number. I wanted to predict sales that comes in numbers, right? If I wanted to predict weather that comes in number, then it becomes a regression problem, right? So under the regression, we have linear regression, nonlinear regression, we have SBR, GBR, we have ensemble methods, we have decision tree. Decision tree also, they can solve both the classification as well as regression problem. Some of the classic decision trees are like classification regression tree, neural networks, so on and so forth. Then we have the unsupervised learning. What is unsupervised learning? In supervised learning, we had a response variable in place. We had a target in place. In absence of a target, then it becomes a unsupervised learning problem, right? And unsupervised learning, broadly the clustering problem. We cluster our data on the basis of the similarity or the homogeneity. What are the popular algorithms under the unsupervised learning family? Clustering, k-means, hierarchical clustering, Gaussian mixtures, neural network, hidden markup model, right? Just for your intellect curiosity, what you see today, the LLM, right? And what you see today, the LLM, right? That is basically the inception point of the LLM was hidden markup model, right? You can verify from ChatGPT how the LLM has come into the picture, so and so forth. But whatsoever we perform under the hood of either we solve a machine learning problem, either we solve the neural network problem, either we solve a uh, AI problem, right? Broadly, we carry out the four type of analytics. The four type of analytics, like you see in the y-axis, different what kind of analytics that creates value, like the descriptive analytics, right? What happened? What is the goal of the descriptive analytics? Right? The goal of the descriptive analytics to develop a better understanding the raw data you have in hand, right? Under the descriptive analytics, we perform like like the descriptive statistics we apply in order to develop a deeper understanding about the measure of location, measure of dispersion, measure of position, measure of shape, graphical data analysis, so on and so forth, just to develop a better understanding about your raw data, the characteristics and nature of the raw data. Then moving up, we have the diagnostic analytics. Why did it happen? The diagnostic analytics are typically like uh, also known as the root cause analysis, right? The variable we have in hand, there are certain domain where there are 100 numbers of variables are there. The variables we have in hand, we wanted to figure it out. I wanted to identify the number of input we have, which of the input variables contributes maximum to my response or target variable, the root cause analysis. Some of the popular technique we apply for the diagnostic analytics, such as feature selection, some of the graphical representation like your cause and effect diagram. Then we have Pareto chart. The cause and effect diagram and the Pareto chart is also part of the 7QC tools, right? So in the industrial statistics, right, it applies heavily in the production environment or in the industrial scenario or for the Six Sigma projects, right? So they apply heavily this diagnostic analytics. Then moving up, we have something called predictive analytics. What does it mean by the predictive analytics? And you see, in the y-axis, the more you are moving up, you are creating more value to your projects. Predictive analytics, right? What will happen, right? So the prediction, forecasting, what we saw like regression, classification, all these algorithms, they are capable of predicting something. What you saw the visualization tool like Tableau, you saw like Power BI, right? These tools are meant for the visualization, 360-degree view of your data you have in hand. It does not give you the power for the prediction, right? Then we have something prescriptive analytics. How can we make it happen? What does it mean to you, prescriptive analytics? Because like we say, prevent before it happens, right? Suppose we are predicting something which is unusual, which is not in our this thing, so we can prescribe the corrective measures in order to control that event, prevent before it happens, right? Prevent before the damage are done. So this is the broadly the four type of analytics we perform irrespective of projects we undertake, right? Either we take a data analytics projects, business analytics project, data science project, machine learning projects, AI projects. This is broadly four type of the analytics we perform. Then moving up, what are the best practices? How do I ensure which of the framework we should use in order to ensure that we can complete and we can win with our projects? right? So what you see in this infographics, this was of the workflow of the past from your journey from data to wisdom or data to knowledge or data to uh, insights. What we have been doing in the past, we have been doing the data acquisition, right? So as we saw, you need to acquire the data or you need to import the data, right? Multiple formats. It could be database, it could be real-time data, streaming data, right? So you need to bring those data for your analysis. Then data preparation, step two. And this is more crucial component of your projects and the critical path of your projects. Data preparation. What the sources reveals, data analyst or data scientist, they consume in between 70 to 80% of their time for data preparation. It could be cleaning, it could be filtering, data transformation. There are multiple challenges comes, right, during the data preparation. And you need to ensure your data is ready for analysis, right? Then application of analytical algorithm, right? So we have multiple algorithms are there. We are living in a very, very blessed time. We have multiple algorithm. So you need to identify which type of problem it is, which of the algorithm fits in order to approach and solve the problem. Then report generation and dissemination, right? So once I applied, performed all the three steps, I need to save my report or I need to document all my work in order to share with my stakeholders, right? So this was the workflow in the past. Now there is another, the advance when the data mining came into the picture, right? Because the data science is an upgradation of data mining. So the data mining fraternity or the data mining community, they work out one of the framework, the standard framework, and what the sources reveal. Suppose you follow this framework, your chances of completing and winning the project increases in between 30 to 40%. If you do your project directionless without any framework, right? And if you do your projects following these framework, your chances of completing and winning will be 30 to 40% more. So what is this framework is all about? The framework basically comes in the business understanding, data understanding, the business understanding, or defining your goal or research understanding for the academician or the researcher, right? You need to define your business goal, then your data understanding, right? So you need to identify which are the appropriate data we need to have to support our projects, right? Then data preparation, right? So as I said, in the section of the data preparation, it consumes in between 70 to 80% of your time in the data preparation. Then we have modeling, right? Then these three components are common for both the conventional data analytics cycle and in the data mining, right? Until data preparation, it was common. What has changed from this modeling? What we saw in that infographics of difference between the data analyst and a data scientist, right? The modeling. What do you mean by the modeling? We will be coming to that, right? Modeling is nothing but that is the equation or the function we generate when we apply an algorithm, right? Then evaluation, right? Once we build a predictive model, through this evaluation, we collect the evidence. What is the percentage of the accuracy we can claim from the model in case of prediction, in case of deployment? Deployment means I build a regression model that we are going to see in a very quick minutes. right? How we can get into deploy this model for the purpose of prediction. So this is the framework you please keep in mind. So that will help us during our dealing with the capstone projects as a part of the agenda we have defined, right? I'm skipping lot many slides in best interest of the time. We are done with the data science overview, trends, technology, and typical application, data science concepts and best practices. We discussed about the conventional data analytics workflow. We discussed about the best practices, then data science popular code, right? So what are the data science popular coding languages are on demand in marketplace? We experience like Python, R, uh, right? Uh, then also we saw something like the Spark, so and so forth. Then now data science with low code, no code tools. Then so now we will be getting into the data science, no code, low code tools. During the section of the data science low code, no code tools, we will be exposing is one of the software called Statistica, right? So this software has been there in the marketplace since 1984, over 4 decades now. And we have been associated with the Statistica since 2007 in India, right? So this is the tools we are going to expose, and in this tool also support, right, all the programming language, not limited to R or Python and Java. It support also Visual Basic, C Sharp, that we are going to show you in a couple of minutes, like all in one, right? So what the software that brings, whatsoever the component you saw in data science, right? Database management, visualization, statistics, AI, machine learning, right? Your data mining, everything you can perform not using a single line of the code, right? So data scientist is not exclusive for the coder or computer science engineers, right? So those who understand the concept, they can apply all this basic to the advanced algorithm also, not using a single line of the code. Open standards. In addition to that, again, what we saw in the job market demand, right? The pharmaceutical manufacturing industry, they are also one of the highest recruiter with the skill set, right? Not only the highest recruiter, as far as our experience goes, they're one of the best paymaster also, right? So the software also has the capability of to prepare you for a process engineer, quality control engineer, Six Sigma consultant, so and so forth. And this is not new things we are exposing to you. In India, around 600 academic customers, they have been using Statistica. That includes all the old 7 IITs, ISIs, IEMs, right? So many of the premier institutions, they have been using the tool. Fine. So let's get started with the how I can perform the data science using the low code or the no code tool. Screen. Hello, can you
Yes, sir.
please prompt answer? Can you view my screen?
Yes, sir.
Okay. Uh, so what we saw in the data science component, let me rephrase you again. What are the components in the data science or the necessary skills required to become a data scientist? So these are the skill sets required, the necessary skill set are required to become a rock star data scientist, right? So like talking about the technical component or the technical skill, not the soft skill of the upper sphere, databases and data processing, visualization, statistics, so on and so forth, right? So what do you see in front of your screen now, right? This is the first interface of the software Statistica, right? So this looks like just like an Excel, right? So if anyone is exposed to Excel, right, they can start using Statistica, even not writing a single line of the code. Fine. So they can use the Statistica. These interface are known as the ribbon bar, right? If I follow my pointer, if I click this, because this interface has changed to a typical drop-down menu, right? This is known as your classic menu. So that is the second type of the interface, right? If I wanted to switch from one to another, I can go to and I can switch the interface, right? In addition to that, in addition to these two type of interface, we have another interface, what is typically known as visual data science interface. So through every visualization or through this icon approach, you can apply any of the data science component what we saw. So what it is doing now, we are solving a credit scoring problem, right? This is the data set of the credit scoring, right? And we are solving a credit scoring problem. Like, so at the moment, a borrower comes to a bank in order to take the loan, right? Here, this is my response variable. We have labeled in the bad and good. This is the good debtors. This is the bad debtors. So these problems, since you may remember when we discussed about the supervised learning problem, right? So we solve regression and classification. Since my target is labeled in classes bad or good, then it becomes a prediction classification problem, right? So at the moment, a new applicant comes to a bank for a loan product. It could be a housing loan, it could be a credit card, right? So on the basis of this classification model we build, we can predict the applicants will pay me back or not, right? So we can estimate the risks to giving the loan to the applicants. Fine. So this is the credit scoring. So here on the credit scoring, we are subsetting the data, right? Training and testing. Typically, we split the data in training, testing, validation. Then we are doing a random sampling. We are approaching some of the decision science algorithm or the classification or sorry, decision tree algorithm like classification regression tree, boosted classification tree, random forest, so and so forth. And here we are deploying the model, right? And all these component I have in control, right? If I wanted to make any changes or something like this, we can do so. So this is the third type of interface in this low coding. No, no, I am not a Python. I am a typically like the R coder. If I wanted to do with the R, no, 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 I don't know because I'm a typically a C programmer. I wanted to do in C sharp. No, 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 I cannot do in C sharp. I wanted to do in the Visual Basic. So you see, because here I got the Visual Basic node, here I got the Python node, here I got the C# code, here I got the R node. So it's basically the language of my choice or my capability. I can solve this credit scoring problem using the data science no code, no low code tool like Statistica through this visual data science approach. Or if I'm good in Python, I can apply the Python code here, Statistica support. I can apply the Python code here. If I understand the R, I can write the R code here within the Statistica IDE. If I understand the C#, I can also write the C# code in order to solve this prediction classification problem, credit scoring. If I understand the Visual Basic, I can also not necessarily I have to have a Python coder in order to solve this problem, right? So that is the reason we had said all in one, right? It is your choice. It is your best of the skill you can apply in if you are conceptually clear. What this tool provides you, as I say, for the database management, right? Statistica support broadly around 165 formats, right? As we saw, there are 90% of the data comes from the unstructured formats. So any of the formats are there. It could be CSV, it could be text, it could be Excel, it could be any of the similar kind of the software. The Statistica can import the data in a click of a button, right? In addition to the format, Statistica also support your databases. We saw like the database is one of the necessary skill to become a data analyst or a data engineer or a data scientist. So Statistica support all the databases, the SQL databases, right? So you need not to be a database administrator or database advanced skill set you have, right? Through drag and drop, you can acquire the data from the databases, any kind of the SQL kind of databases. It could be Microsoft SQL, it could be Oracle, it could be Postgres, right? Any of the SQL database you can bring this. In addition to this, Statistica also support your advanced data acquisition like ETL, right? Extract, transform, load. This is a very, very advanced concept. Now this ETL has been upgraded to the ELT, right? But conceptually, if you are comfortable with ETL, right? So then you can perform this advanced data engineering function also using the graphical user interface. If you are not conversant with any kind of the concept about what is ETL, the Statistica provides you the help and support. I do not know much of the ETL, right? So I can go to the Statistica example. I can go to the ETL. In the ETL section, there are 3 examples has been listed here. So, and the step-by-step instruction has been given, right? If I go to the data set, the data set, because 100 of inbuilt example data sets are available in Statistica, right? So this is what I can do in the database management. That is one of the component. Then get into the visualization. After database management, we had the something called visualization. Statistica, typically known as the king of visualization. So you get all the 2D graphs, histograms, scatter plots, scatter error plot, back plots, mean plot, you name it, you have it. Then we have the 3D graphs, raw data plots, bivariate, range plot, box plot. Then we have the 3D XYZ, this I get, right? Then I have the matrix plot, right? Then we have the icon plots. Today, what you see the emoji, right? The Statistica had long before, right? So you get all this in form of the Chernom faces. Through the facial expression, you can describe the property or the emotion, right? From this Chernom process, the graphical representation. Then we have categorized histogram, scatter plot, you name it, you have it in Statistica. So you also can perform all the visualization activity using just drag and drop, right? If you are conceptually clear, right? Then come to after the database management, visualization, then come to the statistics, right? So what all the statistics are provided or I can perform using this no or low code tool. Under the basic statistics, I can do descriptive statistics, correlation metric, t-test independent by groups, t-test independent by variable, t-test dependent samples, all this hypothesis testing, Brecht ANOVA, so on and so forth. Then I can do the multiple regression, ANOVA. Under the ANOVA also, I can perform all the four type of ANOVA, one-way ANOVA, main effects ANOVA, factorial ANOVA, repeated measures ANOVA. Then we have the distribution fit. Then we have the non-parametric, right? I understand you understand what is the under the hypothesis testing, what is parametric test and what are non-parametric tests, right? So these are the non-parametric test I can apply using 2 by 2 table, observed versus expected correlation, so on and so forth. Then we have the distribution fitting. I hope you all understand about the distribution. What is the importance of the distribution? So the distribution let you know about your characteristics and the nature of the data, right? So we have all the distribution. Then you have the more distribution. We have the simulation also. Under the simulation, we have Monte Carlo Latin square. So all these things you can do in a click of a button. So let's do like how easy it is, the Statistica operation. I'm pulling a data just to show data set. I pulled a data. On the top of the screen, you can see we have 12 phi. Phi denotes to variables. The column represents the variables, gender, eye color, hair color, height, so on and so forth. And the C denotes to cases observation. So this is a data set which are inbuilt in Statistica, right? You can convert this data set into the CSV or Excel or any of the formats for your practices. I wanted to perform a descriptive statistics here just to develop a better understanding about this data. So I went to statistics, basic statistics, descriptive statistics, variables. Currently in best interest of time, just I am dealing with one variable's height. I can, and if I click the show appropriate variables only, it will display only the variables which are eligible and qualified to perform the specific test. So currently I'm just dealing with the height, or I can choose randomly, sequentially, right? So there are multiple ways I can choose the variable, right? There is no limitation. Okay. If I get to the summary, I get this all this valid number of observation, mean, minimum, maximum, standard deviation, right? If I go to the advanced, right, select all the stat. So I get all this in addition to this, I get geometric mean, harmonic mean, standard deviation, skewness, kurtosis, all the four type of descriptive statistics in one go. So I get all this output like this. If I wanted to explore the data visually or through visualization or through graphs, I can get all these graphs in one go, right? So I get a histogram, I get a probability plot, I get a box and whisker plot. If I wanted to do a data normality check, I can uh, go to the data normality and I can apply the Sapir-Whorf test. Right? So I got the Sapir-Whorf test. I got the p-value, right? So I can have a deeper understanding. The variable we're dealing with, the height, that does not follow a normal distribution because my p-value is the less than 0.05, right? So you can conclude. So we need to further check our data, the variable called height, which of the data points which of the data points which contributes to these non-normality, right? So this is the way we can perform under the statistics. Again, under the statistics, we have advanced algorithm like linear model. Under the linear, you can perform the simple regression, multiple regression, factorial regression. Uh, yeah, Chetna ma'am, what I will do, we have kept a exclusive question answer session, right? So you may ask there. Chetna ma'am, can you hear me? Hello. Fine. This is all the simple regression, multiple. All right, simple regression, multiple factorial regression, all you can do. Again, if under the nonlinear model, you can perform logic model, profit model, multinomial logic model, ordinal logic model. You need this like the basic to the advanced model, everything you can perform not using a single line of the code, right? But subject to you should conceptually clear. Fine. So let's again like what we saw under the data mining. We saw some of the popular algorithm from the decision tree. So you can perform general classification tree, regression tree, shared model, interactive trees, booster tree, random forest, mass splines. You can perform the neural network. You can perform machine learning. For all basic to the advanced, the operation will remain same. The way we perform the basic descriptive statistics, similar way, right? We can perform from basic to the advanced algorithm. We have been talking about the web scraping, right? We can do the web crawling. We can do the text mining. So we can retrieve the data from your PDF. You can retrieve the data from your websites, some unstructured data through our this thing. Right. So let's solve a problem. Let's get into the agenda. Data science with no low-code tools, data science data to deployment capstone projects. So how we can perform a data science capstone projects, not using a single line of the code. I'm picking a data from Statistica inbuilt example data set. poverty. So I got a data set from Statistica inbuilt example. Yeah, so let me get you the description of the data and what the projects we are going to deal with. Here I do have a raw data. So from the raw data to deployment, how we can complete the whole project management life cycle. If I wanted to see the data description, right, I can go to the all specification, right? The population change, the data, the volume of the data is the 30 number of cases. What I can see from the top, 30C, that denotes to the cases or observation. I do have the 7 fee that denotes to your column or the variable, right? And what you see in these cases or the rows, right? The Benton, Cannon, Carroll, these randomly picked up from the county or equivalent to states in India, Bonton, Cannon, Carroll, all these stuff, right? So this is the state of the United States of America, and they have picked up the data. There are 30 observation or 30 state they have picked up the data, and the data describe the variable describe at population change between 1960 to 1970, not employed, PT poor, tax rate, right? Number of persons employed, percentage of people below poverty line, residential and farm property, percentage of residents with telephone, PT underscore rural, percent of rural population, median age, right? That is the description of the data. So what they have recorded and they wanted to solve the percentage of people living below the poverty line, right? So this PT poor, that is our response variable. My government has given me a task, right? Let's see investigate the PT poor, right? I see the 13.2, right? That is the minimum percentage of people from this 30 observation or the 30 county or state we have. The minimum percentage of the people living below the poverty line is the 13.2. That is the minimum we have achieved so far, right? Now my government has given a tax. I do not know what you do. You need to correct your this input, this population change, work this any area and bring down the poverty from minimum 13.2 to the 10%, right? You take what necessary corrective measures are required in order to bring this poverty percentage of people living below poverty line, which is currently the minimum percentage we have achieved 13.2. We wanted to bring it down to 10. Right? Since we observed the data, right? So all are in numbers, right? My target or response also in numbers, right? And I do have the multiple variables. So it has become a multiple regression problem, right? So I went to the statistics. I went to the advanced models under the, because this is linear model, right? So that also we can figure it out from the distribution, right? My data are linear or my data is curvature, right? So on the basis of that, my data understanding, we can, since my data consists of multiple input variable and my target response variable is continuous in nature, that has become a regression problem, right? So let me choose the variable of my interest. PT poor, that is my response variable. Rest of my is my input variable or independent variable. I have chosen my variable. Okay, right? So I got a output on the basis of my selection. I click the all effects. So once I got the all effects, I get a ANOVA table. I understand you understand the interpretation of the ANOVA table, like the concept. If your concepts are clear, the tool could be Statistica, the tool could be Python, the tool could be R, the tool could be anything, right? If you understand this table, under the R, you use any software, the table description will remain same, right? Here in Statistica, what it has it made it easy because it has coded the, you see, the intercept pop underscore change or the population change has and the PT rural, it is coded in red, right? So what does it mean, right? It means since the p-value is less than 0.05, we can make an interpretation with an evidence. This population change and percentage of people living in rural, they contribute maximum to percentage of people living below the poverty line, right? But you use any software and whole model R, right? So again, you use any of the software, maybe the coding or maybe non-coding, you get similar kind of the table, right? So you need to conceptually clear what should be the interpretation of the multiple R, right? Multiple R square, adjusted R square, sum of square model, DF model, or the ANOVA table, right? Let's see, because here my objective, if you understand or you remember the CRIPS framework, first was the business understanding. So what is the business understanding here? Business understanding is that we wanted to solve a socio-economic problem, right? To reduce the poverty from 13.2 to 10%, right? And the data, we thought these are the indicators or these are the input appropriate, like this population change, uh, right? The population change, percentage of people having telephone. These are the appropriate variable, the data understanding. Then data preparation, we have skipped some of the assumption here in best interest of the time, but not this thing, right? So, but that we can do also in a click of a button, right? Then modeling. Modeling means, as I said, the step for modeling is nothing. You need to have a equation or the function. So here I went to the report and I go to the prediction equation, right? So I got the equation here. So that is the heart of the everything we do under data mining. This prediction equation or the model. Let me copy this. Fine. And in the same option also I can go code generator. I am saving this model in the PMML. The PMML stands for the Predictive Model Markup Language. I got the code. I'm saving this PMML code. This is a very, very popular. You can deploy this PML code in most of the commercial software. I think the Microsoft Azure also support the PMML code. If I have this PMML code, I can deploy in Microsoft Azure, as I said, for the deployment or democratization of analytics or data science, where your model can benefit to the millions of people, you can deploy this model. I save this model, right? Now I go to my data mining. I had a target. My government has given me a task to reduce the poverty from 13.2 to 10%. I will do some optimization here, load the model, I'm loading the model, what I had saved. Here, I wanted to achieve 10%. I put 6 target value. My target value is the 10%. Here, I am using one of the optimization technique is simplex. In addition to the simplex, Statistica also support the grid and the random sampling also, random optimization algorithm also. I optimize this, right? So this is the iteration has happened. In 80 iteration, I have achieved my desired target, the 10% poverty. Let me see what are the input, what are the measures I need to take in order to achieve the poverty to 10%. I need to adjust the parameters like the population change in 19.65, right? The not employment, not not employment independent 15, or you can make a note of these numbers, right? So this is the input if I work on and I can get, then very well I can achieve a poverty of 10%. Let's deploy this model. Let me add one case here. The new case, add cases. I'll be using after 30. Okay. Here I added one of the new cases. I'm receiving a new data. Already I built a model. I'm putting the Odisha because that is a new state. I'm receiving the data. Since I come from Odisha, so I'm putting the Odisha. I received the new data. New data I work on 19.65. Then I have 1586.63. PT poor has to be blank because that is what we are going to predict now, right? Then 0.79, my tax rate, then 82.88, okay, it has been rounded up. Okay, 82.88, here 19, 15.8663, right? Then I have PT rural as 25.08. My age is 30.94, right? So this is I got. Already I have built the equation modeling step 4 in the CRISP framework. Now let's deploy the equation. Go to the transform. I had copied the equation, so I wanted to plot all these prediction numbers in V8, right? That is, I have created a new variables, or I put the prediction, right? Okay. Uh, what is the number now? Can someone please respond? What is the number now? Because suppose I make this adjustment like my population changed 19.7, 1 point, my not employed 1586, my tax rate 0.79, pretty phone 82.88, right? Age 13.94, then our prediction will be the 10%. Suppose we adjust our parameters, then we can have this 10.0. Then it comes to something. I don't have a Statistica. Why necessary I will have this commercial software? I need to purchase something, right? Not import this thing. So we experience the two-way from raw data to deployment. One with deployment using the PMML code, predictive model markup language. Another we did within the Statistica. We have a very unique feature called transform where you can apply all the expression. Now we have a challenges. I don't want to use Statistica. I have that prediction equation in my hand. How can I deploy this model? So I can go, I can save because I'm good in Excel. Can I do it in Excel? I save this data in Excel, same data set. A2, then I have to B2 C because the C, the percentage of who are living below the poverty line, I have to predict, right? So here I'll put E2, E2, F2 and E2. Is 19.65, 15.86, then I have 0.79, 82.88, 25.08, 13.9. Okay, somewhere hopefully I have done a mistake, but I'm getting the 10C. I am getting the prediction here, right? So hopefully somewhere, uh, but this is the way like we can get the prediction, right? So it is not necessarily the whole concept. If you understand the multiple regression, if you understand the equation, right, you can deploy anywhere, right? So here this is the your no coding, low coding tool. You can do everything what you saw the data side. Not necessarily you need to become a coder. You can perform everything using this. But again, if now you can see these infographics right in front of you. What we have been doing here, we have been performing using Statistica IDE. Here you can see the Python node, right? So if you are, we are doing with using Statistica the same operation, histogram, histogram using the same. operation, drag and drop through the visual data science, the same approach, right? In addition to that, if I understand the Python, right, I can write the Python code here also, right? So because there are certain integration is required or configuration is required to integrate the Python. Similarly, I can write the SVB code. I can write the R node, like I can write the R code also, right? Let's say if I run this R code, I get the output here. So under the hood of one platform, I can do all in one. I can write all this code skill which is required in the market like R, Python, C Sharp, Java, everything I can perform using the all-in-one tools like a no coding, low coding tool, Statistica. And mind it, normally the workflow will remain same whenever you are undertaking any of the predictive analytic projects. It could be machine learning, it could be data science, right? If you have the skill set, the necessary skill set, what we experience now, what, which kind of the domain you can aspire to get a job, right? Which are the domain and what are the typical application you can solve if you have the skill set, what we discussed now. You can go to a market research organization, right? In the market research organization, you need to have uh, the skill set like the customer insight, customer churn retention, market basket analysis, media mix optimization, price optimization. These are the typical application. If you go to a market research organization or you go to a marketing analytics department, right? If you develop your understanding in solving this kind of typical application, or you develop a language once you are going to the Hindustan Lever or Procter and Gamble, right, for an analyst position, for a data scientist position. If you say, no, I can solve a customer insight, I can solve a customer churn and retention problem, that will obviously impress your recruiter, right? I can solve a market basket analysis. Typically, day in, day out, these are the day in, day out applications that perform a typically a market research company or the consumer company, so on and so forth. If you go to a finance, if you apply for a data scientist position into a banking financial organization, maybe a ANZ Bank, American or ICICI Bank or SDFC Bank, right? If you say, no, sir, I can solve a credit scoring problem, what we saw, right, through visual data science approach, I can solve the customer analytics problem. I can solve fraud detection or the anomaly detection, risk management, churn analysis, Sarbanes-Oxley scorecard, right? So depending on your aspiration, you can develop some kind of the domain knowledge in terms of the application. Then improve quality, fraud detection, claims management. If you go to a healthcare, right? So if you start talking about these kind of the application you can approach and solve, your chances is certainly it will impress your recruiter. Pharmaceutical manufacturing company. We saw the pharmaceutical manufacturing company, right? The pharmaceutical manufacturing company, they're also one of your largest recruiter for data scientist and the skill set, right? You have. So if you go to the product traceability, stability and self-life analysis, validated reporting and analytics, compliance, manufacturing analytics, right? So the manufacturing analytics, this is an area is not explored by many of the candidates who comes with a statistics background. This is one of the very promising area to get a job but it is not well explored by the typically like the statistician, right? This is one of the quick uh, success for this kind of uh, in the manufacturing analytics, right? If you go to the manufacturing, typically like the Tata Steel or JSW, or you go to the core manufacturing, if you talk about, I can solve the yields, what we saw in terms of this optimization, we could bring the poverty from 13.2 to 10% in couple of minutes, right? We could solve a bigger problem. Similarly, like suppose you can talk closer, I can improve your yield, right? Through optimization, you are achieving 95% from your this thing. You wanted to improve more, like you have the potential to achieve 97%. You can do the similarly, like by applying the appropriate algorithm, optimizing the yield, right? So the chances of getting recruitment will be much more faster. Fine. So the message is that, right, if the data is everywhere, you can apply analytics anywhere, and for and any of the domain could be a destiny, right? Or or could be a career destination, right? It's totally depends, but the necessary skill, what we saw in the data science infographics, you should have the necessary skill, and you can approach to any of the domain, right? To so what should be the next? What should be the next from this merchandise, right? If any of the participants are interested, they can buy the session recording. We have recorded the session, the whole session, unedited version, right? Plus the PDF version, what we shown you some of the slides, that is we have collected and curated over 10 years of experience. You get every answer from this PowerPoint slide. So it consists of 135 PowerPoint slide. You can get a PDF version of the PowerPoint slide. Then you get a 30 days of NFR Statistica software. What you saw in this no coding, low coding tool, you can have a 30 days not for resale Statistica software. Then plus you get a electronic textbook, known statistics methods and application, plus 35 video tutorials, plus 1 hour mentorship from me, right? All it will cost you only a very, very initial discount at 999 rupees, right? Those who would like to continue their journey with us as a full stack online, full stack program on a foundation program on data science. The mode will be online. The duration will be 40 hours, right? This 40 hours will spread in 3 months, right? And the format will be 80% will be hands-on practical and 20% will be the concept. What we saw, some like the regression concepts, right? What is the concept of the descriptive statistics? So 20% will be concept and 80% will be hands-on practicals. We'll expose to all the tools what you saw, Statistica, R, Python, Visual Basic, C Sharp. So you get a solid foundation. It will be include 24 of 25 hours training plus 10 hours capstone projects. The way we solve the projects for your poverty reduction, right? A socioeconomic problem plus five hours mentorship, right? So this will value you if you'd like to continue, but it is purely optional, right? 14,999. Terms and condition, all classes will be online, right? The classes will be happening online, 4 hours weekend batch. These classes will be happening on Saturday and Sunday only, no weekdays, 2 hours each, or that could be mutually flexible or adjustable. Bring your own device. All the participants, they have to arrange their own laptop, right? The time in the weekend between 11 a.m. to 6 p.m. This is the time we could be flexible, but this is the window of the time 11 a.m. to 6 p.m. Then we have the special terms for the full stack DS participants, right? So those who will continue with us for the full stack program, a foundation program on data science, and if you complete the program successfully, certain conditions apply here. Certain conditions means not large condition or the hidden condition. Only you should be very, very regular in attending the class. And for every session, we'll conduct some kind of the internal the exam. If you secure 80% average in the exam, up to 5 candidates will be offered internship at a fixed stipend of 15,000 rupees per month if not placed within 1 month completion of the course. If you complete the full stack program of 40 hours, 3 months, and after completion, if you do not get a job within 30 days of the completion, we will absorb up to 5 candidates. As I said before the presentation, like our colleague Preetha and Praveen, they were also in the other side couple of months back, but they have not come through. They have not gone through of this training program, right? Uh, mm, but they are in today. Uh, in this side. But another thing like if you get a job, again, that is the hidden terms. If you get a job within 1 month after completion of the course or during the uh, uh, probation of your course, you need to share your 50% of salary of first month with us, right? In addition to that, those candidates, we are not undermining anyone paying capacity or the purchasing power. Anyone who comes with a BPL card holder with 50% marks, all the things will be free for them. We won't charge a single penny, and we will help them to get a data science as a career destination. Fine. So for any kind of the queries, you may contact in this email ID, biswajit@greatanalyticsindia.com, biswajit@statsoftindia.com, India office at greatanalyticsindia.com. And this is my phone number, but I would request only the WhatsApp, right? 98913 93138. Now we would open for all the questions you have in mind from these